comparing decimals, which is larger, 0.0098 or 0.05? Well, one way of doing this is to add trailing zeros so that both numbers have the same number of digits to the right of the decimal. The first number, 0.0098, has 4 digits to the right of the decimal. The 0.05 only has 2 digits. So if we add trailing zeros, we get 0.0098 or 0.05, and then we're adding 2 zeros here. And then so then we can, the place value corresponds to the number of digits after the decimal. The place value, or the denominator of the fraction, corresponds to the number of digits after to the right of the decimal. So the first digit would be the tenths, or denominator 10, and then hundredths, and then thousandths, and then 10,000ths. So here we have tenths, hundredths, thousandths, and 10,000ths. So the denominator here is actually understood to be 10,000. So this 0.0098 is a fraction, 98 over 10,000, and this decimal here as a fraction is going to be 500 over 10,000. And now we can compare the numerators. 98 is less than 500, so the 500 is the larger number. So 500 is more than 98. So that means that 0.05 is more than 0.0098. So that compares those two numbers. Okay. Okay. So here's another example. Recorded rainfall in Smallville for the last 20 days in inches. We have 0.03, 000, 0.1, 0.05, and so forth. And we want to complete the following: frequency distribution, number of days where the rainfall was between 0 and 0.09, the number of days between 0.1 and 0.19, and so forth. So we notice here that the largest number of decimals, digits after the decimal point, is 2. 0.03 has 2 digits after the decimal. 0.1 has 1 digit. 0.05 has 2 digits. So if we add trailing zeros so that all of these numbers have 2 digits to the right of the decimal, then it makes it easier to compare. Okay, so the 0.03, we can leave that alone. So we'll have 0.03, and then 0, if we add trailing 0, 0.00, 1, 2, 3, 4, 1, 2, the 3 of them, 0.00, 0.00, 0.10, we can add a trailing 0, 0.05, so that's that first row there. Second row, 0.06 already has 2 digits after the decimal. 1.3, you can add a 0. 1.8, add a 0. 0.1, add a 0. And then we have 1, 2, 3, 4, 5, 6, 7 that are just 0. 0.00, 0.00, 0.00. I have a little bit of a dry spell there. 1, 2, 3, 4, 5, 6, 7. Okay, and then the last row, we only have two numbers in the last row. We have 0. These already have two digits to the right of the decimal. 0.49, 1.09, 0.07. Okay, so then now that we have the same number of digits after the decimal, it makes it easier to compare. I also added extra zeros in the chart here at the bottom. 0.03 is between 0.00 and 0.09, so that goes here, and then all the zeros will go there. 0.00, 0.00, 0.00. 0.10 would go in the next row here. 0.10, 0.05 goes is between the first row of the chart. 0.06, 0.06, 1.30, that goes, that's over 0.49. So 1.30, 1.80, 0.10, another second one, 0.10 here. And then we have a bunch of, we have 7 zeros here. 2, 3, 4, 5, 6, 7. And then 0.49, I'll go in the second to the last row here. And 1.09, and then 0.07 goes up here. Okay, so that now we've grouped these, and let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have 14 between 0 and 0.09. 14, and we have two days where the rainfall was between 0.1 and 0.19. 2 days, and 1 day where it was between 0.4 and 0.49, and 3 days where it was over 0.49. Okay. So that's our frequency distribution. Okay, so that so that sort of gives us an idea of how the rainfall was distributed. Most days there was no rain, and then it looked like a skewed right distribution. We have some days when it's rained. Usually it rained quite a bit. On most days where if it did rain, it rained quite a bit. So that just kind of gives us an idea of how the rain was distributed. Okay, another example of comparing decimals. Later this semester we'll be using the p-value to test hypotheses. For example, testing whether a new drug is more effective than the old drug. The p-value represents the probability of making an error, so a low p-value indicates strong evidence, and we'll use this chart to interpret the p-values. And so a p-value between 0.1 and 1, little or no evidence. A p-value is never going to be more than 1. P-value is a probability, and if an event is certain to happen, it has probability of 1. It's always going to be between 0 and 1. But if it's between 0.1 and 1, we'll say little or no evidence. Between 0.05 and 0.1, some evidence. 0.01 and 0.05, moderate evidence. 0.001 and 0.01, strong evidence. Between 0 and 0.001, very strong evidence. We'll say more about what this chart means later. So if researchers testing a new drug report a p-value of 0.073, we want to know how strong the evidence is. So it'll be help if we add trailing zeros to our chart in order to compare this, make it easier to compare. so we want our p-value has 3 digits to the right of the decimal. This is what we're going to use to compare. So if we add trailing zeros, so that all these have 3 digits to the right of the decimal, this is going to be 0.0100. This will be 1.000, 0.050, 0.100, 0.010, 0.050, 0.010, this is 0.000. So now all these numbers have the same number of digits. It just makes it easier to compare. So then the 0.03 is going to 0.073 rather is going to be between 0.050 and 0.100. So the numerator here is 73, and the numerators, so it's going to be between numerators 50 and 100. So 50, 73 is between 50 and 100. I'm just looking at the numerators, 50 and 100. So 0.073 is between 0.05 and 0.1. Okay, so that means the adjective we want is some. The sample provides some evidence that the new drug is better than the old drug. Okay. Okay. So another example of comparing decimals. Later this semester we'll also be computing z-scores, which tells us how far above or below the mean a score is. So a z-score of -2, below -2 or above 2 is considered unusual, and we want to use the number line to interpret each z-score. So the z-score of -2.34, -2.34 would be, this is part A here, it's about right here, and that is that's it's between -2 and -3, so it's to the left of -2, so that's the unusually low range there. So it's unusually low. Okay, a z-score of positive 3.72. That's going to be on the positive side. So the number line has 0 in the middle, and then if you go to the right, you have the positive numbers 1, 2, 3, 4, etc. If you're going to the left from 0, you have the negative numbers -1, -2, -3, -4, and so forth. So positive 3.72. That's between positive 3 and positive 4. It's on the positive side. And this is part B, and this would be unusually high. Unusually high. Any z-score above 2 is unusually high. Z-score of -1.76, that's part C. I already marked it down here, -1.76. It's between -2 and -1. It's not unusual. Okay. And z-score of 0.45, that's between 0 and 1. That's part D, and that's also in the not unusual range. Okay. Okay, so that concludes this presentation.